Okay, so this is the last video in a series of for the power series. We're going to go through this hopefully pretty quickly, um, so I don't run out of time. Let me go ahead and set my timer so I don't lose track of it. All right, so we're going to find the interval of convergence now. Earlier we were just finding the radius, and what I was technically doing, like for example on this problem, wasn't 100%. There's one more step you had to do to find that interval, and that's what we're going to be doing now. So let's go ahead and take this example right here. I know it's centered at 0, so let's go ahead and now do the interval. The ratio test. The limit as n approaches infinity of x to the n plus 1 over n plus 1 times n over x to the n. Absolute value of that, the limit as n approaches infinity of the absolute value of x to the n times x times n divided by n plus 1 times x to the n. And then from here we can clearly see that this guy here cancel out. So I'm going to rewrite this. I'm also going to pull the x out. And the reason why I can do that is because this limit is in terms of n, not x. And then now I can clearly see, that n plus over n plus 1, the limit as it approaches infinity is 1. So this whole thing equals the absolute value of x. Well, remember that we need the absolute value of x to be less than 1 for it to converge. So then I'm going to rewrite this. This is equivalent to saying negative 1 less than x less than 1. Now that's what we've already done before. We got this. But now we actually have to test each endpoint because it could be equal to, it could be or not equal to. So that's what we're going to be looking at now. So I'm going to take negative 1 and 1 and plug them both into this series right here to figure out, will it converge at negative 1 and 1. So you're going to, so negative 1 to the power of n over n. And if you recognize this, this is called the alternating harmonic series. And we discussed this and previously, and we know this converges. So I can put an equal to here, and it's going to be correct. Now, the next series, n equals 1 to infinity of 1 over n to the, and that's the power of n. This is just the harmonic series. So this is going to diverge. So our interval of convergence will be this right here. The interval of convergence is from negative 1 to 1. And x has to be somewhere here in this interval for the series to actually converge. Okay, so now what I'm going to do, let's go ahead and do another example of that. So it'll be Alright, so negative 1 to the power of n, x plus 1 to the nth power, all divided by 2n to the power of n. Alright, so I'm going to go ahead and jump once again, centered at negative 1. So I know that the middle of my interval will be negative 1. I'm not going to, once again, I'm going to drop the, using the ratio test, we can drop the negative 1 to the power of n, because since it's absolute value, it'll knock out the alternating part of it. Okay, so here's my ratio part. I'm going to go ahead and expand both of these because they will cancel out nicely. All right. And then from there, I can clearly see that this guy simplify, this guy, and this guy simplify. So now I have the limit as n approaches infinity of x plus 1 over 2 absolute value of that. All right, now that there's no more n's, I don't really need this anymore. So I can just say x plus 1 over 2 absolute value. We want this to be less than 1. So I'm going to go ahead and say, well, x plus 1. Let's go ahead and drop the absolute value bars. Okay, multiply everything by 2 to get rid of this divided by 2. And then I'm going to subtract 1 from everything. Okay, so now what I need to do is, so we know we did it right for starters because I know it's centered at -1. -1 is dead center of this interval. Now I need to check to see if it's equal to here or equal to here. And once again, we're going to plug both of these values into here to see if that works out. So -3 plus 1 to the n over 2 to the n, which equals, I'm going to simplify that a little bit. And it looks like that these two negatives are going to cancel out and it's going to simplify to 1. So this negative and this negative will always cancel each other out, so I don't need that part anymore. And then I have 2n over 2n, which is just 1, which diverges. Because you have 1 plus 1 plus 1 plus 1, and it'll keep on adding all the way to infinity. So this diverges. So I know that at -3, I'm not going to put an equal to sign onto it. So now let's plug in 1 and see what happens. Plug in 1, we get 2. Well, now that's going to simplify with that. Okay, so this doesn't actually ever really, it's not going to work out because we're going to consider it to be divergent. Because all it does is switches back between -1 and 1, and -1 and 1. And it's going to keep on doing that forever. So it's going to go back and forth between 0 and -1 and 0 and -1. So it's actually not going to converge. So therefore it diverges. So this is my interval will just simply be -3 less than x less than 1. That is my interval of convergence. Okay, so let me go quickly describe the homework for you. Go ahead and, so first off, 5 through 8, I want you to go ahead and do all of them. This is on page 659. And once you do all of them, it's just simply finding the center. 9 through 14, from this point on, do odds. So this is all for 5 through 9. 9 through 14 is finding the radius. This is just finding that r value, which remember is 0 if there's no radius, if there's only a single number, infinity if it's all real numbers, and then the other number, which we did in this, I think, the second example. And then 15 through 31 odds is the actual interval process. And if you have any questions, remember that I am going to be on my office hour every day in the morning. I will let you all know if that changes. If you have any other questions, please email me and I'll do what I can for you.